Dear friends, today we shall discuss about some properties of plane meters. Here you see we have taken a plane meter, right? And a chessboard here. You see black and white. Some of the pins we have taken, and also something written on the paper, right? Today we will prove the properties of a plane mirror, right? What are the properties of a plane mirror? We know that in general there are three properties of plane mirror. The first property of the plane mirror is that the image formed by a plane mirror is erect. The image formed by a plane mirror is erect. The image formed by a plane mirror is virtual. And the image formed by a plane mirror, or you can say the distance between the object from the mirror and the image from the mirror is equal, right? And the last one is the image formed by a plane mirror is laterally inverted. We will prove all this property of the plane mirror in an experiment you will find here. First one is, we will prove that in a plane mirror, the image formed by an object is erect. Let us find. Here we have taken some Here we have taken some pin and we'll take suppose you've taken a pin and put it here, right? You see the image formed by the plane mirror is like this. What the impedance is? We got the impedance that this one is the top, right? And this one is the end of the pin. You see, in the image, this is the top, this is the end, right? That means the image formed in a plane mirror is always erect. You see this one. This is the head, this is the end, right? In the image also you'll find, you see, in the image, you'll find that this is the head and this is the end. You see, this one is our original pin and this is the image also. You see, this is the head and this is the end of the pin. That means the image formed in a plane mirror is always erect. Let us take another pin, right? Let us take another pin. Suppose we are taking another pin here. See, this one green pin, or you can take it here also, right? Green pin. Here also you can see that the head, this is the object, and this is the image. You see, in the image also, you see the head is upside and the pin is down. That means we can prove from this experiment, and we can take another pin also. Let us take another pin. Here I am taking another pin, right? Blue pin. Here also you see, this is our object. The head is upward. In the image also, you see the head is upward and the end is downward, right? That means we can say that in plane mirrors, the image formed by plane mirror formed is always erect. In this experiment, we proved that the image formed by a plane mirror is always erect. Let us take another pin from this direction, right? Let us take another pin, this red pin. Here also you see that this is the object, this is our object, and that is this is the image. You see the object, in the object the head is upward, and the image also the head is upward. That means the image formed by a plane mirror is always erect, right? We have proved this in this experiment, right? Now let us take the second property of plane mirrors. Let us take the second property of plane mirrors. What is the second property of plane mirrors? The second property of plane mirror is that the distance of the object from the plane mirror is same as the distance of the image from the plane mirror. Let us prove this property. Let us take this. Here you see, we have taken for this, what we have taken? We have taken a chessboard, right? We have taken a chessboard here. We have taken a chessboard, and we are going to prove that the image formed by a plane mirror, the distance of the object from the plane mirror is same as the distance of the object from the plane mirror. For that we will put here, you see here, I am putting an pin at this position. What is position? That is at the first square. You see here, first square, right? Then you can see that the distance of this object from the plane mirror is this distance, right? And here also you see the distance of the image from the mirror is same as that of the object. The image is formed after one square, right? If I move this pin to the second square, there is one black and white, you see? That means we can say that if I move this pin after two square, you see this first square is black and the second square, you see carefully, here you see the first square is black and the second square is white. That means we replace or place this pin after two square, this square and this square, two square, And you see the image also. Let us see the image. Here also you see that in case of image also, you see this one? The image also, the image moved after two square. That is, one is black and the second one is white. That means the distance of the object from the mirror is same as the distance of the image from the mirror. Let us take another pin. Let us take this pin to third square. Let us take another pin, that is green pin. Third, we are taking after third square. This one is first. You see here. This one is first square. We are putting this after third square. This is white, black, and white. I am putting this square after third square. You see this one. That means the distance of the object is first square black, first square white, then black, then white. There are three squares, right? That means distance of this object from the mirror is 3 squares. And in the image also you see, in the image, that the distance of the image from the plane mirror is 3 square. That means the distance is same, right? We can say that the distance of the object from the plane mirror is same as the distance of the distance of the image from the plane mirror. Let us take another example. Suppose we are taking this pin, red color. I am putting this pin after one black square. Here you see, after one black square, we are putting this pin. Here you see, here also you see. Here also you see that this red pin, this one, red pin is distance of 1 square from the plane mirrors. And in the image also you see, the distance of the red pin is 1 square behind the mirror, right? I will take another square, blue. I am taking blue square and putting this blue square after 2 square. Here you see this one, black, white and black. You see here, right? Blue pin. That means we have taken the blue pin after 2 squares. One is yellow, white and then black. In the image also you see the blue pin is also at a distance of 2 squares. One is white and the other is black, right? That means we are finding here in this case. Let us take another pin. That is why I am taking here. This is the first square white, then black 2, third white, fourth black, fifth white. I am putting this pin after 5 squares. You see 5 squares. Here also you see, if we count this pin, this one, how much distance it is? It is, you see, this is the white first, second is black, third is again white, fourth is black and fifth is white. That means the distance of this red pin from the plane mirror is 5 squares, length of 5 squares, right? And let us take the image. Here you see, this is the image of the red pin. Here, this one, right? Here also if you count the squares, first one is white, then black, again white, black, and then white. That means the image is 5 squares behind the mirrors. From this experiment, we can say that an image formed by a plane mirror, that means the distance of the object from the plane mirror is same as the distance of the image from the plane mirror. That means if the pin is after 2 squares, the image will also form after 2 squares. In this way, we can prove that the distance of the object from the plane mirror is same as the distance of the image from the plane mirror. This is the one property of plane mirror, right? The first property proved that the image formed by plane mirror is direct. The second property proved that the distance of the object from the plane mirror is same as the distance of the image from the plane mirror, right? Now we will prove that, and we also know that in a plane mirror, the size of the image and size of object is same, right? And the last one, but not the least, that is the image formed by plane mirror is laterally inverted. For that, we have taken, here you see, for that we have taken a paper, written something on it. Here you see, we have taken a paper, written something on it. If we take this paper in front of the plane mirror, let us find what is written on the plane mirror, right? Let us take. Here you see, if we take this paper, in front of the mirror, let us read what is written in the paper. Here you see, the image formed we get is ambulance. But in the paper you see, it is written laterally inverted. Here you see, this paper, we cannot read this one, right? Here you see, we cannot read this one. Here you see, this paper you see, this one, we cannot read this one because it is written as laterally inverted. Laterally inverted means we see the left on the right side and right on the left side of a plane mirror. That is laterally inverted. Let us take again this written something in front of the plane mirror. Here you see, we can read that the written something is ambulance, AMBULANCE. Also see in the right, it is written as AMBULANCE, right? That means we have proved all the properties of a plane mirror. The first property of the plane mirror is that the image formed by a plane mirror is direct. We proved this one. The second property is that the distance of the object from the plane mirror is same as the distance of the image from the plane mirror. And the third property is that the image formed by a plane mirror is laterally inverted, right? Laterally inverted means left side will be seen as right will be seen as left. That's why let us take again this paper, right? We cannot read this paper, but if we take this in front of the mirror, then we can read this A, but you see, it is written as ambulance, AMBULANCE. That's why on the front of the ambulance is written in laterally inverted form like this. Laterally inverted form like this. But when you see this laterally inverted by another vehicle in front of it, then it will be seen as ambulance. Emergency for emergency, right? And they will give way for the ambulance to go through, right? These are the properties of a plane mirror, right? And the last one, again we are repeating that the third property is that the image formed by plane mirror is laterally inverted. And also we will prove that the image formed by plane mirror, the height, or you can say the size of the object is same as the size of the image in the plane mirror. Let us take this one. We have taken a pin. Here you see, we have taken a pin like this. Here you see, right? Here also you can see very clearly that if we take the height, you see here, here you can see that if I see through one eye closed, we will see the height of the object and height of the image will be same, right? You take from this direction. Let us take from this direction. Here you see, the height of the image and height of the object is same. Here you see, with the help of this camera, you see that this image coincides with the image of the object. The object coincides with the image of the object. That means we can say that the size of the object and size of the image are same. Let us take another pin also. Here see, we have taken another pin. We have taken another pin, red pin, and we have taken another pin, that is blue pin, right? Now let us measure. Let us observe. Here you observe that if we take this camera here and you see here that the image of the green pin, you see this is green pin, the image of the object and the image of the green pin coincides with each other. That means what you can say, that the size formed by this plane mirror is same as the object. But the blue pin also, you see, the object, this object coincides with the image of the blue pin, right? That means you can say that the size of the object is same as the size of the image. And for the red pin also, you see, this is the red pin. This is the red pin. You see, the red pin, this red pin, and the image of the red pin coincides with one another. Here you see, we can say from this experiment that the size of the image and size of the object is same. In the conclusion, we are saying again that there are four properties we have proved in this experiment. The first property is that in a plane mirror, the image formed is erect. The second property is that the distance of object from the plane mirror is the same as the distance of image from the plane mirror. And third property is that the height of the object or the size of the object is same as the size of the image. And the fourth property is that the image formed by plane mirror is laterally inverted, what is we know as lateral inversion. Lateral inversion means left side will be seen as right side and right side will be seen as left side. Again, we are explaining this one again. Here you see something is written in this paper, but it is written as laterally inverted. If we see this written in the mirror, then what we are seeing, you see here. Here you see, in the mirror we can see it is written ambulance AMBULANC. That means we have proved all the property of a plane mirror. The first one is the image formed by plane mirror is erect. The second property is the distance of the object and the distance of the image is same. And the third property is the size of the image and the size of the object is same. And the fourth property is that what is written or the image formed by plane mirror is laterally inversion, what is called, we called it as lateral inversion. Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video.